Let's take a look at this practice test for the rational number equations that we've been working on. So some of these hopefully are pretty easy, and then some of them will be a little bit more on the challenging side. Let's take a look at this one right here. We need to isolate the variable term here, so we're going to get rid of that 11/7. We're going to subtract 11/7 from each side. Something nice happens over here. Of course, we end up with a 0. Those combine to be 0. They cancel to be 0. And then we've got already a common denominator right here. So same sign, we're going to find the sum. Those are going to combine to be negative 31/7. And this doesn't reduce, and we're not going to change it into a mixed number. So the nice thing about that one is we're all finished right there. That's it. Next one, we've got 5/6r equals negative 45. We're going to take this, we've got a fraction in front of the variable, so we're going to multiply by the reciprocal. So we're going to multiply by 6/5 on both sides. 6/5 on both sides, and the 6's are going to cancel, the 5's are going to cancel, so we've got our 1r over here. We're going to look to do a little bit of cross cancellation if we can. Remember, if there's a fraction in the problem, we might as well think of everything as a fraction. So the 45's on top and the 5's on the bottom. That means I can cancel this 5. 5 goes in here once, and 5 goes in here 9 times, so we're left with negative 9 times 6, so that's going to be negative 54. So we've got our answer there. This next one here, we've got to isolate that variable right there, so we're going to move this to the other side. I'm going to add 4.8 to both sides. So this is going to be x is equal to, and then over here, again, if you want to check this on your calculator or any of these on your calculator, you're certainly allowed to. But this one, hopefully we can do this on our own. This would be basically 4.8 minus 0.7, so this is going to be 4.1. Let's see, right here we're going to get rid of this by subtracting 3.28 from both sides. So subtract 3.28 from both sides. That's going to move this over there. We're going to get a 0 there, so we've got a negative 1.6 n over here, and then I am going to grab a calculator for this. Let's just double check and see what we've got here. So we've got negative 12.8, and then we're going to subtract another 3.28. Make sure we've typed it in there the right way. Looks good. Negative 16.08. Negative 16.08. We were expecting it to be negative because we were combining the two of those negatives. And then we're going to divide both sides by negative 1.6. Of course, they cancel to be a 1 here, so we've got an n, and then let's throw this in the calculator. So we've got that negative 16.08, and we're going to divide it by, so I'm just going to hit divide. It's going to take that last answer, and we're going to divide it by negative 1.6. And let's see what we've got for an answer here. So we've got 10.05. 10.05. So there's our answer there. So we're showing our work. We're being careful about how we show this. It does say round to the nearest hundredth if necessary, so let's see if we have to do that on any of these. I'm going to blow this up just a little bit so we can take a better look at a few of these. Here's the variable term. We want to isolate that, so again I'm going to move this to the other side by adding 3.3 to both sides. That's going to cancel that off there, so we're going to end up with n over 8.85. And then when we combine the two of these together, again, this might be something that you can do in your head. Let's just double check and make sure. So negative 3.56, and then we're going to add 3.3. Whoops, I made a mistake as far as syntax goes. Oh, I put a decimal at the end there, so let's just get rid of that. So negative 3.56 plus 3.3, add those together, we get negative 0.26, which you probably could have figured out from here, but that's fine. And then we're going to multiply both sides by 8.85. So multiply both sides by 8.85. Grab the calculator. So when we multiply, I'm just going to hit times 8.85. It's going to take that negative 0.26 and it's going to multiply that by 8.85, and we get negative 2.301. So negative 2.301 on this side and n over here. And remember, we want to round this to the nearest hundredth. So here's the hundredth place, which means we look at this digit right here. If this is 5 or more, we'll bump that up. If it's 4 or less, we'll leave that alone. So the real choice here is Is the answer negative 2.30 or is the answer negative 2.31? Those are really the only choices. This is the only number that's going to change there. And that's 4 or less. It's a 1, so we're just going to leave that alone. It's not enough to bump it up. So the rounded answer on this one is going to be negative 2.30. Now if you wanted to, you could just write negative 2.3. That would be fine. Either way there would be fine. Alright, let's take a look at this next one. We need to recognize that grouping symbol, that fraction bar. It puts the two of those together on the top. If you want to put a set of parentheses around them, you can. So we're going to undo that dividing by 3.6. We're going to multiply both sides by 3.6. So on this side they cancel to be a 1, so we have negative 1.8 plus x over here, and let's see what we've got on the calculator there. Let's see, 3.6 times negative 0.14, and we end up with negative 0.504. And then we just need to get rid of this subtracting 1.8. So we're going to add 1.8 to both sides. Now if I were doing this by hand, I would be really careful about lining these up. Really, if we were doing it by hand, this is what we'd want to write. We'd want to write add 1.8. Put the zeros there. We're really finding the difference between the two of those. So let's see what we get for a difference. I'll have the calculator work this out for us. So we're going to do negative 5. Whoops. Make sure we have the decimal in there. 0.504. And then we're going to add 1.8. And we get 1.296. 1.296. And this is a great problem to illustrate some rounding here. We're rounding to this place right here. So this is either going to stay a 9 or it's going to bump up and become a 10. So really the question is it 129 or is it 130? So 1.29 or 130. So if this is a 5 or more, we're going to bump that up. It's a 6, so we are going to bump that up. So the answer on this one is going to be x equals 1.3 or 1.30. Either way you want to write that is fine. Okay, kind of like this one here because it kind of shows that we knew what we were doing when we rounded. But either way is okay. Let's take a look at number 7. Here's the variable term, so we're going to isolate that. We're going to add 7 to both sides. Again, adding 7, that would just cancel that out. So we end up with negative 5/3 v on this side, and then when we add the two of those together, if you want to use your calculator for that, go right ahead. I'm going to do this by hand off to the side here really quickly. So we end up with negative 2/15, and then plus, this would be, let's see if that's a 15 and that was over 1, this would be 105. So we end up with, this is a 103 over 15. And again, feel free to do that on your calculator. We do definitely need to show this work here. We're going to multiply by the reciprocal, so negative 3/5 here, negative 3/5 here. Negative times a negative is a positive like we want. The 3's cancel, the 5's cancel, so there's our v all by itself. And then let's see if we can do any cross cancellation here. Let's see, I've got a 3 and a 15, so 3 would go in here once, 3 would go in here 5 times. And then 103, that doesn't have anything in common, no common factors with either of the 5's down here. So that's going to be 103 times 1 on the top and 5 times 5 on the bottom, so that's going to be 25. And again, we're going to leave it like that. We're going to leave it in improper form. We've reduced it, but we're going to leave it improper. Alright, number 8. We're going to go ahead and, this is a positive 3/8, so we're going to subtract 3/8 from both sides. Those are going to go away, so we've got our 1/8 m over here. I'm going to go ahead and do this one by hand. 7/24 minus, if that were 24ths, I would have had to multiply by 3, so that's going to be 9/24. So that's going to give me negative 2/24, which of course we're going to simplify that, and we're going to write that as negative 1/12. And then we're going to get rid of the fraction in front of the variable by multiplying by its reciprocal. Its reciprocal happens to be 8, but again, not a bad idea to put it over 1. Think of everything as a fraction if you've got a fraction in the problem. So we've got an m over here, and let's do a little bit of cross cancellation here. 4 goes in here twice, 4 goes in here 3 times, so the answer on this one would be negative 2 on the top, 3 on the bottom, so negative 2/3. Alright, Take a look at 9 and 10 here. Let's do some distributing. So this is going to be 12, and I'm going to think of that as over 1 on each of these. So 12 over 5x. This is going to be negative 8/5, and over here we have negative 1/2. And now we've got a regular old two-step equation, so I'm going to add 8/5 to both sides to cancel that off. So we'll add 8/5 here. So we've got 12/5 here, 12/5 x. I'm going to get a common denominator, so this would be tenths. And we would have multiplied that by 5, so that's going to be 5/10. Negative 5/10 would be the same as negative 1/2. And I'm going to double this, so it times that by 2, so that's going to be 16. So let's see, we end up with 11/10, and then again we're going to get rid of the fraction in front of the variable by multiplying by the reciprocal. So we're going to multiply by 5/12. 12s cancel, 5s cancel, so we end up with x over here. And let's see, can we do any cross cancellation? We can right here. 5 goes in here once, and 5 goes in here twice. So we end up with 11/24. And there's our answer for that one. Alright, and we'll take a look at number 10. Distribute through here, and again I'll grab a calculator to help with that. So notice we've got a negative times a negative, so I'm just going to do 7. Let me clear this off so it looks a little bit better. 7 times 3.4. So we're going to have 23.8r. So 23.8r. This one's going to be negative. Now, if you look at this one, you can probably do this one in your head. 2 times 7 would be 14, and 0.1 times 7 would be 0.7. So I'm thinking 14.7 over here. But again, just to double check, 7 times 2.1. There's our 14.7, and it would be negative. And then over on this side, we have the negative 159.88. Regular old two-step equation here, so I'm going to add 14.7 to both sides. That'll cancel that off. So we have 23.8r, and then over on this side, let's see what we've got here. We've got the 14.7, and then I'm just going to write minus 159.88. So we get 145.18. Okay, 145.18. Negative 145.18. Okay, and then of course we're going to finish this off by dividing both sides by 23.8. So 23.8, and let's see what we get here. On that side, of course, we have an r, and then on the other side we've got this division problem, so 145.18, and we're going to divide that by 23.8, and we get negative 6.1, so negative 6.1, so we get a decimal answer on that one. No need for any rounding or anything. Okay, let's take a look at the two of these. We've got a variable on this side and a variable on that side. We want to move the smallest one. So if we think of this in terms of tenths, this would be 6/10. So what we're going to do is we're going to subtract 6/10 k, and I'm going to subtract 6/10 k. That is the same as 3/5, so we're going to go ahead and cancel there. So this is going to be, let's see, that would be 1/10 k. And then we'd have the minus 5/6 equals negative 7/6. I'm going to add this to both sides, so we're going to add 5/6. Again, bringing it over here changes the sign of that, so we've got 1/10 k equals, let's see, what have we got here? We've got negative 7/6 plus 5/6, so that's going to be 2/6. So if that's 2/6, that's the same as 1/3. So we've got, let's see, and that's negative, so negative 1/3, and then we're going to multiply both sides by 10. And again, if you want to think of that as a fraction, go ahead. So when we multiply straight across, we have a negative 10 on the top and a 3 on the bottom, and that right there's the answer. Alright, same type of thing here. Let's do this at the same time. So here's what we're going to do. We're going to move the smallest one. This is the smallest one. So I'm going to add 1/3 b over here. Add 1/3 b over here. So those are going to cancel. And since I'm moving the b's over on the left side, I'm going to move that 3/4 over here. So we're going to subtract 3/4 here. So those are going to cancel. So here's what we've got. I'm going to rewrite this as 2/9 b plus 3/9 b on this side. And since these are in fourths, I'm going to write this as 18/4 minus 3/4. Looks pretty good there. Okay, so on this side we've got a total of 5/9 altogether, 5/9 b. And on this side we've got 15/4. 18/4 minus 3/4 would be 15/4. And then we're going to get rid of that fraction in front of the variable, so we're going to multiply by 9/5. Cross cancel here. Do a little bit of cross cancellation here. 5 goes in here once, 5 goes in here 3 times. Let's see, we can't cross cancel the 3 or the 9 with the 4, so we end up with, on the top, 3 times 9 is 27, and on the bottom 4 times 1 would be 4. Okay, so there's our answer on that. And then let's take a look at these next couple. So we've got some word problems here. This one just says define a rational number and give 4 examples. So let's just make sure we remind ourselves and understand what this is. So a rational number, I'm going to use the hashtag for number. Remember, the root word is ratio, okay? Is a rational number can be written as a ratio of 2 integers. And if we give some examples would be things like this. So 7/9, something like that would work just fine. The number -10, totally okay. 2.3, if the 3 is repeating, that's fine. If we've got a decimal like 0.75, that would be a rational number. 0 is a rational number because that would be like 0/1. And then it also says, describe how you can tell if a decimal number is a rational number. Well, remember, if they're rational numbers and they're in decimal form, they either terminate, they stop like 0.75, or they have a repeating pattern. So we'll write this: a decimal is a rational number if it terminates or has a repeating pattern. Okay, we'll take that. That'll be just fine. Okay. Give 3 ways to write a over b as a negative fraction, and one way you cannot write it as a negative fraction. So we've talked about this a couple times. So when we write a negative fraction, we can write the negative out front. We can write it on the top. We can write it on the bottom. So those are the 3 ways that are okay to write a negative fraction. What we can't do is we can't write this. We can't write negative a over negative b, because a negative divided by a negative would be positive. Okay? Alright, let's take a look at number 15. So here we'd want to solve these equations. We'd want to write down what happened in the problem. Write it as an equation, maybe declare a variable, and then solve that. So it says Amy had $19.21. She bought 15 candy bars and had $4.36 left. How much was each candy bar? So she had $19.21. She bought 15 candy bars, so that means she's going to subtract something from her money, 15 times the number of candy bars, and she's going to end up with $4.36. And this is a pretty good choice of a variable here because it reminds us what we're looking for. So we're going to say C equals candy bar, cost of a candy bar. Okay? And then we'll go ahead and solve this. So we're going to, we're going to subtract 1921 from each side. So we're going to have negative 15c equals, and then let's see what do we have here. If we do 4.36 minus 19.21, we end up with 1485, negative 14.85, and then we're going to divide both sides by negative 15. And notice what's going to happen here. This is going to end up being a positive c, which we would expect for the cost of a candy bar. And we've got a negative divided by a negative. That's going to end up being positive. So we're going to take 14.85 and we're going to divide that by 15. and we end up with 0.99. So that means 0.99. Now, there's the equation. We've declared our variable, and we solved it, and we got this right here. So, but what does that mean? It says how much was each candy bar. So we're going to say each candy bar was 99 cents. Okay, and if we write 99 cents that way, 0.99 of a dollar, we put the dollar symbol in front. Or we could write this. We could say 99 cents and the cent sign goes behind. Okay, probably prefer that way right there. Okay, last one. Let's see. Michaela got a paycheck and put 2/5 of it in her bank account. If she put $32.96 in her bank account, how much was her paycheck? So she put 2/5 of her paycheck. We want to know what her paycheck was, so we'll use P for paycheck. And she put 2/5 of that. 2/5 of. Remember, the of usually means multiply. So 2/5 of her paycheck was, so that's how much she put in, $32.96. So we've got the variable, we've got the equation, and now we'll just solve the equation. So when we solve that equation, we're going to multiply both sides by the reciprocal. So that's going to be 5/2 here and 5/2 here. Those are going to cancel, so we're going to end up with P over here, and then we'll go ahead and do this part on the calculator. So we'll do 32.96, and then we'll times that by 5 divided by 2. If you wanted to do 2.5 or something like that, that would be totally okay, but I've kind of typed it in so that it looks a bit like a fraction. We end up with 82.4. So 82.4. Now, there's the answer to the equation, but the problem said how much was her paycheck. So please don't do this. Don't say paycheck was 82.4. You've got to at least put the dollar sign in front of it, and you've got to remember that we're talking dollars and cents here, so you definitely want to put the 0 there. 82.4 would be 82.40, $82.40. So you want to make sure you add that 0 at the end so you know how many cents there are. All right, there you go.